Well, good morning again, my fellow students. Well, for you it's morning, but for me it's evening, as usual. So, day 10, hey, we're about halfway there for this first half of the trimester. Another 10 days or so and we'll be done. So, I am going to finish up factoring with you, and then we'll end up finding why we factor. Why do we factor? Okay. And we'll find that we factor to find the zeros. But before we get there, I'll review some important steps in factoring. So, and these are the steps you should consider when you factor. Number one, you factor before you factor. Factor out leading negatives. That will make factoring much easier, and I'll go through each of these examples. Number two, for our trinomials, ax squared plus bx plus c, where the leading coefficient a is not equal to 1, use the crisscross method to help you factor. Okay, yesterday when we factored, the a coefficient was always 1, so it was easy. All we had to do was find factors of c that gave us b. Today we'll have to find factors of c and a that gives us b. And then number 3, remember difference of squares. If you forget difference of squares, use the crisscross method. I will illustrate each of these 3 steps right now. Okay, number 1, factor before you factor. Factor out leading negatives. So here I have an example, negative x squared plus 5x minus 6. Okay, if I were to start this without factoring the negative out, I would have like negative x and x. That would give me my negative x squared. That makes trying to find factors of negative 6 that gives me positive 5 a little difficult because I have that negative with that x. So what we want to do, as I told you yesterday, we want to factor out the negative. So I'll factor out the negative, and then I get x squared minus 5x plus 6. We just reverse the sign of everything inside. Now, that's easy to factor. Factors of 6 that add up to negative 5 are negative 2 and negative 3. So I'll have x minus 2 times x minus 3. Now it's factored. Okay, see how easy that was when you took out the leading negative? Makes it much easier. All right, the second step. For trinomials, ax squared plus bx plus c, where the leading coefficient a is not equal to 1, use the crisscross method. Okay, some of you may be familiar with this here. I want you to notice that the leading coefficient is not 1, it's 2. So now we have to find factors of 2 and negative 6 that gives us a positive 1. Well, that's going to be a little difficult. So what I always suggest for students to do is you want to write your factor table for 2x squared and your factor table for negative 6. So let's do that. So I have 2x squared. And factors of 2x squared, well, it's only 2x and x. 2x and x multiplied together will give you 2x squared. And then factors of negative 6. Well, let's list the factors of negative 6. So I have negative 1 and 6, or I have 1 and negative 6, and then I have a negative 2 and 3, or I have 2 and negative 3. Okay, so where does the crisscross method come in? Well, this is what we do. Okay, over on the right of that cross, we're going to write factors of 2x squared, 2x and x. And then what we're going to do, we'll just multiply across, and what we'll try and get using factors of negative 6 to get 1, because we want a 1x, so we'll multiply across. So let's see here if we can figure this out. So what you're doing is you're looking at factors of negative 6 that when you multiply going across will give you a positive 1. So here I see if I take 2x and I multiply it by 2, that will give me 4x. And then if I take x and multiply it by a negative 3, that will give me negative 3x. Okay, now negative 3 times 2 gives me my negative 6. Right? But if you if you crisscross here, so if I go if I go 2x times 2 is 4x, and then x times negative 3 is negative 3x, and 4x minus 3x gives me my positive x. All right, so there. So I had a positive 2 in the bottom, and rather than writing my negative right there, I'll write it right there. So 2x was multiplied by 2, and then x was multiplied by negative 3. So there are my factors. All you have to do is read them across. Factors. Those are my factors there. So to factor 2x squared plus x minus 6, the factors will be 2x minus 3 times x plus 2. And I'll do another one with you. But if you FOIL, you'll see that's what you get. 2x times x is 2x squared. And 2x times a positive 2 is a positive 4x. And then negative 3 times x is minus 3x. And then negative 3 times 2 is a negative 6. And we get 2x squared plus x minus 6. See, as I told you, what we're doing when the leading coefficient a is not equal to 1, we have to find factors of 2 and negative 6. That gives us 1. It's a little more difficult. A little more difficult. So I'll do another example. So here again, the leading coefficient is not equal to 1. I have a 3, and then I have a negative 2. And we want to find factors of 3 and negative 2. That gives us a negative 5. So again, I'll list the factor table for 3x squared. It's only one pair of factors, 3x and x. And then I'll list a factor table for negative 2. So either I have a negative 1 and 2, or 1 and negative 2. Right? So we'll be looking at those factor tables there. So again, we do our crisscross here. Again, on the left, our factors are 3x squared, 3x and x. Now I need to multiply 3x by a number, and then I'll add that product to x times a number. But I want a negative 5. So I'm looking at this table here. What can I use? I see right away that if I multiply 3x by a negative 2, that will give me negative 6x. And if I multiply x by 1, that will give me x. And negative 6x minus a x will give me my negative 5x. See, I was using that pair of factors right there. And those are so it's factored. So you just read the factors across. It's factored. So this is 3x plus 1. The factors are 3x plus 1 times x minus 2. FOIL and see, we'll get 3x squared minus 5x minus 2. All right, so when the leading coefficient is not 1, okay, use the crisscross method. I was shown the crisscross method a couple of years ago by a student who came from Lake, and I said that's pretty neat. I had always told students to use the tables like I did there, okay, to help you figure out how to factor. So I guess I'm doing what I've done before, but I'm using the crisscross. The crisscross is a visual way to figure out what's going on here. But you're also looking at the tables, and I've always taught that. All right, so there. Makes it easy peasy. Crisscross method. All right, now we'll go on to the third step here. Remember difference of squares. Or if you can't remember difference of squares, use the crisscross method. So what does the difference of squares say? First and foremost, what we say is if that monomial term is a perfect square, and that monomial term is a perfect square, and we're taking the difference, okay, then a squared minus b squared will factor a plus b times a minus b, or a minus b times a plus b. It doesn't really matter. All right, so what do we mean by perfect squares? Well, here, I'll list some perfect squares for x's. Well, x squared is a perfect square because x times x gives you x squared. X to the fourth is a perfect square because x squared times x squared gives you x to the fourth. Yeah, so those would be perfect square variables. Numbers, 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 2. 9 is a perfect square because 3 times 3 is 9. And so on and so forth. So when we have a binomial, two terms, and it's separated by a minus, and the first monomial and the second monomial are perfect squares, then we can factor that as a difference of squares. So x squared minus 4, so what we say, well, the square root of x squared is x. So when I go to factor this will be x, and then the square root of 4 is 2. Okay, so when I factor this, looking at difference of squares, that will be x plus 2 times x minus 2. The square root of x squared was x, and the square root of 4 was 2. If you forget, if that's difficult, you could always do the crisscross method. Okay, we still have our x squared. Well, I'm not even going to write the table because it's so simple. So you have your x and your x, and then there's only one way. But for negative 4, I mean, you have these possibilities: negative 1 and 4, or 1 and negative 4, or 2 and negative 2. So the only possibility, you want to get 0, right? Because you don't have a b term. That b term is 0. So you want to find a pair of factors of negative 4 that adds up to 0. Well, it's only one pair, 2 and negative 2. So it's plus 2 minus 2. Crisscross method will give it to you too. All right. Let's look at some more difference of squares. So notice 4 is a perfect square. 4 is a perfect square number, and x squared is a perfect square variable, and 1 is a perfect square number. So I take the square root of 4x squared, I get 2x. I take the square root of 1, I get 1. So there, I'll factor. So that will factor 4x squared minus 1 will factor 2x plus 1. Using the difference of squares again, that up there, 2x plus 1 times 2x minus 1. Difference of squares. Next example here, 9x squared minus 25. Notice 9 is a perfect square number, and x squared is a perfect square variable, and 25 is a perfect square number, and we're subtracting. So take the square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. And then the square root of 25, the square root of 25 will be 5. So this will be 5. So then I will factor that then using difference of squares, 3x plus 5 times 3x minus 5. Completely factor. See, again, you can check when you FOIL. 3x times 3x is 9x squared. It's 9x squared. And then 3x times a negative 5 is negative 15x. And 5 times 3x is plus 15x. And then 5 times negative 5 is negative 25. See what happens with difference of squares? That middle term always just goes away. Okay. The middle term goes away. And you're just left with 9x squared minus 25 is what we started with. Okay, so I've covered all the factoring with you. We did trinomials yesterday. And then we did binomials yesterday. And then we looked at some more cases. Factor before you factor out that leading negative. What do we do when the leading coefficient a is not 1? And using difference of squares. And I've taught you the crisscross method. All right, so done teaching factoring. Now we use it. So this is where section 5.3 actually begins. Why do we factor? Answer, to find the zeros, roots, or x-intercepts of a quadratic function. It's the only reason we factor. Okay, algebra is all about solving equations. And we need to factor to solve equations. We need to find the zeros. So let's look at what that means. Here I have a quadratic function. F of x is equal to x squared minus 6x plus 8. What does it mean to find the zeros? Well, it means this. Set the quadratic equation equal to 0. Or set y equal to 0. So f of x, remember, is y equals x squared. F of x is the same as y. We want to set y equal to 0. Okay, we have to set one side of the equation equal to 0. That's what it means to find the zeros. Or it's also called finding the roots. So we set that side equal to 0. So 0 equals x squared. We set y equal to 0. And then we factor. We factor factors of positive 8 that add up to negative 6. Well, that would be x minus 2 times x minus 4. And it's equal to 0. So I have two factors. I have x minus 2 and I have x minus 4. So what I have to do is I have to set each of those factors equal to 0. Because after all, if a times b equals 0, then either a equals 0 or b equals 0. All right, or they both equal 0. Okay, so let's look at this. So we want to find the zeros of x minus 2. Well, you just set it equal to 0 and solve. X is equal to 2. You said x minus 4 equals 0. Then solve. X equals 4. So those are my zeros. Now let's take a look at the quadratic function. It is plotted there for you. I want you to notice that you see that graph, the red line, the parabola, crosses the x-axis or y is equal to 0 at x is equal to 4, which is what we found, or x is equal to 2. Graphically, that's what it means to find the zeros. Find where that quadratic function crosses the x-axis. That's why I say it's also called find the roots or the x-intercepts, where the graph crosses the x-axis. Solved. Let's look at some more examples. So, that screwed up. I wanted here. That actually screwed up here. So now remember, what was that equation before? So we were so initially it's kind of like screw. I hope the rest of it hasn't screwed up. No, okay. So we have we had initially negative x squared plus 5x minus 6. If you look up above, and then I factored out that negative, so that gave me x squared minus 5x plus 6. And then I found the zeros. So let's see here, factors of a positive 6 that add up to negative 5. That was x minus 2 times x minus 3. Again, we're finding the zeros, so I should set the equation equal to 0. Negative x squared plus 5x minus 6 equals 0. I forgot to do that. We are finding the zeros here. One side of that equation has to equal 0. Okay, so get out of here. Oh, I hate this. All right, and so what we do, we just set each factor equal to 0. We set each factor equal to 0. I have x minus 2 and x minus 3. So x minus 2 equals 0. X equals 2. And then x minus 3 equals 0. X equals 3. I found the zeros. If you look at that graph of that parabola there, that quadratic function, you'll see that the zeros do cross at 2 and 3. It crosses the x-axis, crosses the x-axis there. Let's look at some more that we did. So remember this one here, finding the roots or zeros. So we set 2x squared plus x minus 6 equals 0. Right? And then when I factored that, I got 2x minus 3 times x plus 2. Just let me verify. 2x times 2 is 4x minus 3x gives me a positive x. Negative 3 times 2 gives me negative 6. We set that equal to 0. All right, and then we find the zeros of each factor. 2x minus 3 equals 0. 2x equals 3. X equals 3 halves. X plus 2 equals 0. X equals negative 2. So those are my zeros there. 3/2, and -2. Let's look at the graph. There I see the -2. That's the -2. And then here's the 3/2, 1 and 1/2. There's the 1 and 1/2 there. I found the zeros or roots. Let's continue on. This is one I did before. So this was a difference of squares. Remember, we factored that. So x squared minus 4 equals 0. We're finding the zeros. And that was a difference of squares. X plus 2 times x minus 2 equals 0. And then I said each factor equal to 0. X plus 2 equals 0. X equals -2. X minus 2 equals 0. X equals 2. And I see my zeros there. -2 and 2. So for homework, you'll be given problems like this. It says find the zeros or roots. Okay, so h of x equals x squared plus 4x. That means set h of x equal to 0. 0 equals x squared plus 4x. Okay, so recall how to factor binomials. Okay. So there's no number I can factor out. I have a 1 and a 4. It's nothing I can factor out there. The only thing I can factor out is an x. X goes evenly into x squared and x. Alright, so this is going to equal 0. And then I factor out that x there. And then I have left over x squared divided by x is x. Plus, and 4x divided by x is 4. It's factored out. Or it's factored. X times x is x squared. X times 4 is 4x. I always verify. So let's find the zeros of each factor. I have two factors. One factor is x. The other factor is x plus 4. I have to find the zeros of both factors. Well, the first factor is easy. X is equal to 0. The second factor is easy too. X plus 4 equals 0. X equals -4. And if you notice, you look at the graph, you see the zeros. -4 and 0. And then lastly, they'll give you problems like this for homework. Find the zeros or roots. Remember, class, we are finding the zeros, which means one side of the equation has to equal 0. Which means I need to subtract, or I need to add 25 to both sides. So I'll have to add 25. I need to make the right side equal to 0. So I have x squared minus 10x plus 25 equals 0. Okay, I didn't give a graph for that. Well, I know what it looks like. It's a happy graph. Hey, I'm going to do some things to review with you here. Anyway, factors of positive 25 that add up to -10. Oops. That's x minus 5 times x minus 5 equals 0. So in this case, though, so x minus 5 equals 0, x is equal to 5. X minus 5 equals 0, x is equal to 5. So if I were to graph this out, it's a happy graph, and it's not going to cross the x-axis, but it will touch the x-axis at x is equal to 5. Let's just review. Okay, remember how to find the axis of symmetry? So A is equal to 1, and B is equal to -10. And the axis of symmetry is x is equal to -b over 2a. So this is going to equal -10 all over 2 times 1, which equals 5. So my h is 5. And then if I substitute that into that function there, okay, what do I get? I get x squared. Well, 5 is x, so I get 5 squared minus 10 times 5 plus 25, and then that will give me, so that will give me 25, that will give me 25 minus 50 plus 25, which equals to 0. So my vertex is 5, 0. And it just so happens when you get a factor twice the same, the graph never really crosses the x-axis as we did in all the other ones. And this is going to be very important for tomorrow's lesson. In fact, it's critical for tomorrow's lesson. The graph never crosses the x-axis, it just touches it. It touches it at the vertex of 5 and 0. And the graph will be a happy graph, and it will look like this. Okay? So, just graphing it out. Anyway, that's it for today's lesson. I know it's kind of long, but I had to combine factoring and finding the zeros all in one. You'll have some homework problems, and then on Friday we begin the next lesson.